We're continuing with our review on page 467. We're on number 16, and we want to decide whether the angles are complementary, supplementary, or neither. So we take a look at our example, and we have a couple of angles, and one of them is 62 degrees, and the other, actually I've drawn this incorrectly. I'll redraw that. So I'm going to start over. So we have two angles. One of them is 108 degrees, and one of them is 62 degrees. Kind of get the idea. And we want to know if they are complementary, supplementary, or neither. And we know that they're complementary if we add them together and they equal 90 degrees. We know that they are supplementary if they add them together and we get 180 degrees. And so if we add the angles together and we get something else completely different, then they are neither. So in this case, 108 plus 62 is 170 degrees. And so in this case, they are neither. Skip a line, number 17. We are they're not touching each other, but if we add those two angles together, 36 degrees and angle 54 degrees, we add them together, we get 80 plus 10 is equal to 90 degrees. And so if we add those two angles together, they are equal to 90 degrees, so they are complementary. And again, you can get the spelling right out of your book, or you can go to your note cards as well. Skip a line, number 18. Again, the angles are not touching, but they don't have to be touching. So we have two angles that are 90 degrees in this case. So of course 90 degrees plus 90 degrees is equal to 180 degrees, which means that those are classified, or we're going to name them supplementary angles. Number 19, we are going to draw an obtuse angle and then measure our angle. So let's take our straight edge, and we want to make this big enough so that we can measure it. Make the rays long enough so we can measure them. And then, so obtuse more than 90, and if we measure this being the center point, we can see that we go from past 90 to 130, not quite 135, so about 134 degrees. And that's our obtuse angle. Number 20. We have angles, it says use the diagram, and our angles 1 and angle 2, vertical angles. Are they vertical? So our drawing looks like this, and we have angle 1, 2, 3, and then this is 28 degrees. All right? So our angles 1 and 2 vertical? And the answer is no. And the reason why, we have to say why not? Because they are not opposite. Vertical angles are opposite. They are not opposite of each other. So no, and then they are not opposite. We have to explain our answer in that one. Number 21, we want to find the, I'm going to put that right on the same page so I have the drawing in front of me. We want to find the measurements of angle 1, angle 2, and angle 3. And so if we take a look at angle 2, we know angle 2 is opposite of the angle that is 28 degrees. So we know right away that that's equal to 28 degrees. So that's our first one that is done. And then we take a look here. There's a couple different ways to figure this out. But if we said that if this is 28 degrees, and we know that angle 1 and angle 2 are supplementary, they add up to 180 degrees, we would simply say 180 minus 28. And in this case, if we subtract them, I'll give you a moment to subtract them. So 180 minus 20 is 160 minus 8 is 152 degrees. So if angle 1 is equal to 152 degrees, angle 3 is opposite or vertical, and so we know that angle 3 is 153 degrees as well. So that gives us all three of our, and we didn't have to use our protractor at all. Let's go to number 22. Number 22, we want to find the value of x and then classify it. So we want to find what is x equal to and then classify and name the triangle based on the angles. So in this case, we have a triangle, and this is 96 degrees, 40 degrees, and we don't know what x is equal to. So in this case, since we have one angle that is, we're going to find the value of x, so x is equal to what? Well, 96, well, take what we know, 96 plus 40, that gives us 136 degrees. We want to know 136 plus what is going to give us 180, because three angles of a triangle always add up to 180 degrees. So 136 subtracted from 180 is going to give us 80 minus 36 is 44. So the value of x equals 44 degrees, and then we want to know what kind of a triangle that is based on the angles. Well, since we have one angle that is more than 90, that's an obtuse triangle. So this is an obtuse triangle, and x equals 44 degrees. Make sure you put down both parts. Number 23, we have this type of a triangle. We have a 48 degree angle, we have a 59 degree angle, and we have what is x equal to. Well, we want to know, first of all, we take a look at all of our angles, and they're all acute. So they're all acute. This is an acute triangle. Then we want to know what is x equal to. Well, 59 plus 48 is equal to 90 plus 17, which is equal to 107 degrees. So 107 degrees plus something, x, is going to equal to 180. So again, we subtract 107 from 180. And so 180 minus 107 is, if we subtract, we get 80 minus 7, which is 73 degrees. So we can say that x is equal to 73 degrees. Number 24, we have this triangle. This tells us that it's equal to 90 degrees, that little box, and 62 degrees, and then we have x is equal to something. So we know right away this is a right triangle because it has a right angle. And we want to know what x is equal to. Well, we have 90 plus 62 is equal to 152 degrees. And 152 plus something is equal to 180. So again, we have to subtract to find the difference, to find that missing angle. And if we subtract 80 minus 50 is 30, and we can't subtract 0 minus 2, so 30 minus 2, the difference between 30 and 2 is 28. So x is equal to 28 degrees. Go to number 25. We want to classify the polygon as many ways as possible. So we have this polygon. This one is a quadrilateral. We know it has 4 sides, so it is a quadrilateral. And we don't know, it doesn't have any sides that are the same. It doesn't have any So we can't really call it a square. We can't really call it a rectangle. It has no right angles. It has no no sets of. We have one set of parallels. We probably could call it a trapezoid, if nothing else. So it's a quadrilateral. It's a special kind of quadrilateral, which is called a trapezoid because, well, maybe not necessarily. I guess we can't even. Oh yeah, we could probably call it a trapezoid if those two sides are the same. So a trapezoid is trapezoid. Gotta spell it right. Has two sets of parallel. One set of parallel. Just one set of parallel sides. Trapezoid. But in this case, our main answer is basically it's a quadrilateral. Let's go to number 26. 26, we have this shape right here. We can say that it's, first of all, it's a quadrilateral. It has four sides. So what kind of a quadrilateral is it? Well, it has four right angles. So we know that it's a square. The four sides are equal. That's right. That's why it's a square. It has four right angles. That makes it a rectangle. It has four equal sides, so that makes it a rhombus. It has two sets of parallel sides, so it's a parallelogram. So we can give a lot of names to that quadrilateral. Number 27, we have a four-sided figure, so it's a quadrilateral. What kind of quadrilateral would it be? Well, it can't be a square, it can't be a rectangle, because there's no right angles. The sides are not the same, so we can't call it a rhombus, but we can call it a parallelogram. So those are our five, and we have two answers there. 28, we have, this shape has five sides, so it is a pentagon. And that's it. 29. We want to know if the triangle is similar or congruent, and then list the corresponding parts. So we have these two. First of all, these are similar. They are the same shape, but they are not the same size. And then if we take a look, we have our shape look like kind of like this, and something like this. And we're going to, the one is flipped around. We're going to flip this one back around, and we're going to say, for example, that if we have, we'll keep that in mind. We have our little marks that'll help us out. And this is A, B, and C, and K, L, and J. So corresponding angles, and we're going to stack them on top of each other. We have angle A corresponds, and angle J. They correspond or match. We have angle C and angle L. They match. And the three little marks, we have angle B and angle K. They match up. Now we want corresponding sides. So we take a look at line segment AB. If we go from A to B, then we want to do the same for same size of angle. So we want to match it up to J to K. So those two match. You can put the little word and, or you can use the symbol. And then angle our line segment C. We can go from A to C, and then from J to L. And finally, this here side here, we say line segment CB matches LK.